Okay, recording started. Okay. Hi, everyone. Thanks for joining Community Call 69. Today, I will be your host. I'm Nimide, and I am a contributor in the Dapr community. So today we have a few topics we want to cover. We're going to go ahead and do a DaprCon update, and then we have a few demos planned. We're going to look at Conformance tests as a GitHub action as a demo, and then we're also going to look at chaos and load tests with Dapr Resiliency. So let's go ahead and get started. I'll kick us off with the DaprCon update. Okay, so if you haven't heard yet, DaprCon schedule has been posted. It's actually already posted on the CNCF site for KubeCon. So actually, I'm going to step away from the slide deck here and just show you. So this is the KubeCon site for KubeCon North America. If you go ahead and click the schedule, and scroll down through everything that's happening, DaprCon is actually going to be on October 25th. So you can click here to add it to your schedule, and the full agenda for DaprCon has been posted here. So thanks for everyone who submitted a CFP. If you have not had me reach out to you, please let me know, but everyone should have gotten an email regardless if your CFP was accepted or not. For the people whose CFPs were accepted, please go ahead and confirm the email I sent out so that I know that you have seen all the next steps. And with that said, I'll go ahead and pass it over to our next topic, which is just going to be conformance tests. Marcos, do you want me to go ahead and present your slides, or do you want to present?
I can share my screen.
Okay, I'll go ahead and stop sharing then.
So can you see my screen?
Yep, we can see it.
Okay. Hello, folks. For those who don't know me, my name is Marcos. I'm a Dapr contributor. I am in charge to pluggable components feature, which is targeting for the 1.9 release. And today I'm going to present a side quest of this feature, which is the conformance test as a GitHub action. So I can skip this slide because I think we have more context to present in this one. So first we should add a little bit more context about conformance tests. What are the conformance tests, and what they are for? First, conformance test is used to test against a building block. And when I say building block, I'm also saying that is implementation agnostic. So it doesn't matter if the building block is backed by Redis or Kafka. If it is a pub sub, it should have, let's say, at least once delivery guarantees, because Dapr is the interface for the user. And as a component says that I am a pub sub, so it should implement at least once delivery. So the conformance test is a way to validate if the component is compliant with Dapr guarantees. The same you can apply for state store. For instance, let's say eventual and strong consistency. If you say that you are strong, you should be. And we have conformance tests to test against these properties. So it hence provides a certain level of confidence. So for instance, it is used as one of the criteria to become stable, to a component become stable. So conformance test is a way to bring more confidence for us as Dapr contributors and for developers who is developing components. So two sides that has gains. Okay, cool. But what do you need this as a GitHub action? Because we actually have some way to test conformance tests. You can write your component, write a YAML file that specifies, okay, I need those metadata to be used. I have these operations to be tested, and this is the test configuration. So I can write few lines in the GitHub workflow that we are having had in the components contrib repository, and other things will work fine, right? Okay, so why do you need this as a GitHub action? Well, this is because the pluggable components feature which is targeting the 1.9 as a preview feature. I will not deep dive in what is pluggable component, but we have an accepted proposal in the GitHub. You can check there. For now, you can assume that is a way to developers create their own components over gRPC. And when I say components, for the next 1.9 release, we have support for state store, pub sub, and bindings probably. So pluggable components allow developers to create their own components, right? So how can we ensure the same properties that we have been ensured for the components control repository? So now, here is a brief design on how it works. It works under a Unix socket. So the Dapr runtime basically connects to a Unix socket using a gRPC stub, which is a component implementation itself for the Dapr point of view. And the component server, the gRPC server, implements the protocol definitions, and it's backed by its dependencies, like let's say Redis or Kafka or Azure or whatever it's necessary to run. And so basically, conformance test as a GitHub action is a way to validate that those components built using the protocol definitions is well implemented or follow the Dapr guarantees regarding pub sub delivery, state store, or another guarantees that we should provide for the user, for the final user. And the conformance test as a GitHub action has basically two phases. The first phase is preparing the component to run against the conformance test. And it requires start the component server, start the component dependency. Let's say if you depend on Redis, you should start Redis as a container. Ensure socket creation. When I say socket creation, I am saying also the file in the file system. And the final operations, metadata, and test configurations as it is today for the conformance tests inside components control repository. And the phase two is basically running the test itself. So once you have a socket defined for the Dapr point of view, it's basically a component behaving as a pub sub, as a state store, or as a binding or secret store, whatever you can create. And then running the conformance stats itself doesn't change from what we have today. It's basically the same thing, but you are testing against a pluggable component. So I don't have any code to show because the code itself is about pluggable component and so on. But I have few logs, example logs that shows how it should work. So I have some bootstrapping here to start my container. In this case, it's the state.redis pluggable component. So it is a Redis component backed by gRPC. And one of the steps is basically run the conformance test itself. So you can see there that the Redis pluggable component is passing for our conformance tests or state store conformance tests. So let's take a look on the YAML file for that. It's on my personal fork. So as you can see, it's just a matter of specifying socket, specifying metadata in a YAML format, specifying the operations that you want to test. You can also obviously specify the type of the component. In this case, in Absent, I'm using state store conformance test, but you can specify. Let's see a more complex file. I think this one. So I can run actually many conformance tests against different components. In this case, I'm just parameterize all the things, and I have like, I guess, 5 conformance tests running against different components. So the all the previous steps right here is to bootstrap the components that I want to test. And this one is just what I need to test to run the conformance test itself. Okay. Let's go back to the presentation. So few disclaimers. First, it's not ready for production, obviously, because it's backed by pluggable components feature, which is targeting for preview features in 1.9. It's my personal fork, not part of Dapr org yet. It works in Unix like OS only because we need Unix sockets to work. For next steps, we have the proposal issue, of course, and the PR for components contrib. It requires few changes, not so much. I think like one file more for the components contrib and Go module, and add the GitHub action for the Dapr sandbox organization. Local run support could be a good feature. Like you don't need to go to GitHub action to start a conformance test. You can, let's say, Dapr run conformance test, something like that. But it's not clear to me, but it could be an option. And as I say, you can't use it even for testing purposes because it's backed by pluggable components feature that's not released yet. It's just a proof of concept that what we can do for the components framework, let's say, or components SDK in the future. And how about certification tests? We do a lot of certification tests for the components as well, but I don't see a feature where certification tests run against a component as a GitHub action because it is really customized by component implementation. It's not implementation agnostic as it is for conformance tests. So yeah. Yes, I think that's it.
Awesome. Sorry about that. I had an issue unmuting there. Great. Are there any questions from the community? I don't see anything in the chat. Okay. Well, if there's no questions.
I have this, Arthur. I have one, maybe not a question, maybe a recommendation that we can create like a community issue to bring this project to Sandbox because we have a Dapr Sandbox org. I think that'd be a great place to incubate these type of projects before it goes into the main Dapr repo. So the main Dapr org. So that would be like a recommendation.
Awesome.
Yes, I agree.
Is that something you'd be able to do, Marcos, to try to see if you can get this into the sandbox?
Yes.
Perfect. Okay, well, if there's nothing else, let's go ahead. I'll go ahead and grab the screen. Share my screen one more time. Okay, can you all see my screen?
Yes.
Perfect. Okay, so let's go ahead and jump on over to our next demo, which is going to be chaos and load tests with Dapr Resiliency. Daniel, I can go ahead and pass it over to you. Do you want me to share my screen or do you want to share your screen?
Oh, I share myself because I will switch to Visual Studio Code for a moment.
Okay.
So, yeah.
Okay, great. Screen's all yours.
Yeah. Okay. Do you see my screen now?
Yes, I can see your screen.
Brilliant. So just a word up front. My name is Daniel. I'm working from Microsoft. So therefore, Nick is basically a colleague of mine. And we had some chat in the past about that resiliency feature in Dapr. And based on that, we had some discussions. And I wondered how easy it would be for a developer to use that resiliency feature. And then also, how can I make visible what it is actually doing and that it actually works? And I found that to get there, I found that it was some kind of challenging, but I came up with a pretty simple demo solution that kind of proves that it in fact actually works. And I just want to show you what I did. And then I'm really interested in hearing what you think about that. Okay, so here's what I set up. I have a Kubernetes cluster running. In that Kubernetes cluster, I have basically two services, my front-end A service and my backend B service. And behind that, obviously, here's one pod. On the other hand, on the backend, I have two pods. And my front end is calling backend B, and the backend B is then doing another call to an external endpoint. In my case, it's just an Azure function hosted, but it could really be any IP address where that accepts an HTTP GET request. And what I did then when I had that setup running is that I injected a chaos into my backend B. Basically, I said I want to have a 5-second delay whenever an outgoing request to that endpoint is done. And that 5-second delay will ultimately lead to a timeout on the backend B, which will ultimately lead to an error in the response for the consumer. So this is kind of the starting point. And let me show you what I did here. So I think that makes sense to just have a look at the code. So just for full transparency, so that you know what's going on. And obviously this is right now we're in that failure mode where we break stuff, and later on I will include Dapr to fix stuff, and then we will try to make that visible that it actually works. Let me try to remove that sidebar here. How can I do that? That's smaller. Okay, so all right, so just a word on the application that is running in my front end and in my back end. This is really just a Node.js based application that has an endpoint, and that endpoint basically just does a request to your target URL. And if that request succeeds, then it will return the result. And if it fails, well, then it will return error code 500. So that's pretty basic, and that's the application that is running on both the front end and on the back end. And one thing to point out here is that I'm passing in some options here, and in those options I'm specifying a timeout that I configure from the outside. I can also configure obviously the target URL from the outside using environmental variables. I think that's pretty basic so far. So when it comes to my front end application, just let's have a look at that deployment. We see that in this case, from the deployment of the front-end application, I do not have Dapr enabled at this point, and I specified the target URL just as backend app B, which is the service name of that backend application we have running here. And when it comes to the backend, I do have Dapr enabled, but it really doesn't matter because I'm not talking to the Dapr endpoint in this case. And I'm using as a target URL that external endpoint here. So basically, this is the configuration so that backend B is talking to that external endpoint. So now if I run, what I wanted to do is inject some chaos. I injected the chaos using chaos mesh. You might have heard about chaos mesh. Chaos mesh is something that you can use to break your Kubernetes cluster. In my case, I'm using that Chaos Studio here on Azure, but you could really use any kind of chaos software that will help you introducing chaos or unreliability into your cluster. So I'm just starting that experiment. And while this is starting, let's have a look at how it is actually configured. And you will see that in the configuration of that experiment, I set that, probably it's a little small, maybe I can zoom in a little. I said that I wanted to delay requests that go out to that external target, which has that endpoint that I'm specified here. And that delay shall happen for one pod of a deployment, and that deployment is identified using that label selector backend app B. So that basically means that not every pod is affected. It's really just one pod of that backend pods that is affected. And obviously, I also specified that I want to do that in my cluster that is called Dapr Chaos Load Cluster here. All right. So that's the specification of that error behavior that I want to bring in. And now to actually prove that an error really happens, I set up a quick test, just a load test. And oops, in that case, I'm using, where's my IP address? Okay, I have to check that. In that case, I'm using Azure load test, but again, you could use any kind of load testing software that you want to use. And you could use JMeter or whatever. Let me check that IP that I need. Front-end app A is behind that IP, so I will take that IP for my load test and we'll run the load test against that. And what we should see, obviously, is after the load test has finished, that there will be some kind of significant error rate because I injected chaos. So all of that is kind of on purpose. I'm breaking my system right now. And of course, I can also do those requests manually. But if I do those requests manually, like using that simple test script here, where I say I want to send a request directly to that IP address just to see if it works, what happens is the following. You see, sometime right now I'm getting that error code, and that's good. That's a good thing because I injected chaos. But if I hit another time, it might actually work. And in this case, it did work again. And therefore, I can't really tell if this is every second time or how often I have to hit. You see, in this case, it worked again, and it worked again, and then it breaks again. It's hard to tell how it behaves up front, and it's also hard to tell to have some statistics about what's actually going on. Therefore, I brought up that load test that is running right now. So let's see how that load test is behaving. You see already 91 requests have been made, which resulted in errors. And as I said, it's kind of expected to have that behavior because I injected chaos on purpose and I wanted to see this fail. So if we wait for another minute or for maybe 2 minutes, probably that test run will have completed and it will probably look like this. Like this. I ran that before. We will probably end up with a screen like that shows an error percentage roughly about around 50%. And I think that makes sense. Coming back to that screen here, if you have an error rate of roughly about 50% and we inject that 5-second delay into one of those two pods, that basically means whenever that specific pod is being hit by my front end, then the request will end up in a timeout, and therefore the user or the load test in this case will also see that error appearing. So this is kind of my starting point, that I kind of proved, okay, I can break my application behavior with that chaos that I injected, and I can make it visible using that load test. Now let's try to fix that using Dapr. And for using Dapr, what I did is, or what I'm going to do is the following. I will enable Dapr on the front end. I will enable Dapr on the back end. I will change the front end target URL, so basically where the front end A is calling, from the service name in Kubernetes to that service invocation endpoint for Dapr running on localhost 3500. And I will configure resiliency inside my cluster, and then I will run a load test again to see if the behavior changed or if it became more reliable. So going back into Visual Studio Code, how would I do that? Well, first of all, I go into my front-end app A, and I will enable Dapr here by uncommenting those lines. And as I said, I will change that target URL. You see here, previously I had that backend B as target URL, and I will comment that out. And I will now use that new target URL for my front-end app A. And of course, I have to make sure that I have Dapr installed as well on my backend application. I had that before, but I wasn't using that Dapr endpoint, that sidecar endpoint on backend B. And additionally, what I did is, if you take a look here in my front-end app A configuration, you see that I'm referring to that app config here. The app config is also applied to the cluster, and it is enabling the resiliency feature of Dapr. And additionally, I configured my resiliency in the following way. I said, I want to have a retry policy here, which is called retry X times. And I said I want to have a maximum of 5 retries whenever a request fails. And I'm applying that retry to all requests going towards my backend app B. So with that, all I have to do now is basically apply that front-end app A file where I did that change. Oops. Let me check where I am. Oh, yes. And I applied the resiliency and the app config already previously, so I don't have to do that again. Now let's go in to make sure if the experiment is still running. If it is still running so that we can start a load test again. Yes, it is still running, and I will start another load test. Also targeting that endpoint again. And while this is running, let's have a look at our pods in the cluster. You see my new pod front-end A is running already. It has 2 containers now in the meantime, which is a good thing. That means that the Dapr sidecar has been installed, 49 seconds old. So this is the new one. And we can also manually test, obviously, if things are running stable now. For that, I can, again, do the request to that URL here manually. This is basically the endpoint of A, which then will call B, which will then call the external function. So this should work stable now. Let's give it a try. Oh, that's not as expected. Let's try that again. Okay, it's working now. It's working now. Okay, it's looking good now. And we can also have a look at the load test, which is running right now. So it is still running, still executing, no errors so far. Let's quickly switch to the old load test that we did previously. That should have ended in the meantime. And we see that brought, again, error percentage of 49% with a total of over 200 errors. And this is our new load test running right here, where I built in the Dapr fix. And so far we have 1 error. And I think it will only take a minute or so, and we should be able to see a much lower error rate. And by the way, of course, it's fun to look at basically Dapr in action. If I just say I want to have an idea of what that that retry looks like, let's have a look at the Dapr logs here of that sidecar, and you will see, where is it? Yes, here, for example, you see here that output that it's actually retrying. So whenever that retry has been mentioned, then that basically means that the first request hit that pod where I injected chaos and did a retry, and then obviously it succeeded, which I find pretty interesting. But let's go back to the result of the test. Let's see if that's done already. Still executing, still only 1 error. So it shouldn't take too long. I think it's always around about 1 minute or so. Right. Okay, still executing. Okay, I don't want to waste your time here. I prepared that already, obviously. What it will end up with is probably something like that. You see here a screenshot of a test that I did previously that was finished with Dapr enabled, with that Dapr Resiliency enabled, and it ended up with below 1% of errors. And I think that's pretty significant when it comes to how reliable the application became. But what I found personally most significant is that I really didn't have to touch application code. This was one of the things where I wasn't really sure if Dapr will be comfortable enough or easy to consume enough as a developer. And what really impressed me is that I really basically only have to change the target URL, which I guess are in most applications configurable anyway. So when I repoint that to that service invocation URL of my sidecar endpoint, then this basically is everything that really needs to change, aside from obviously enabling Dapr. Now let's have another look at whether that test already finished. Now it finished, as you can see here, pretty new. And in my case, it's below 1% error rate for errors. And the only thing really that we did is enable Dapr and switching on that, that resiliency feature. So that basically was that demo. Thanks a lot for your attention.
Awesome.
And if you have any questions, please feel free.
Perfect. I don't see any questions in the chat, but
I have a quick question, Daniel.
Yeah,
This experiment, this like the thing that you put together, is it available anywhere online where folks could try and like dive into the code a little deeper in configuration?
Yes, absolutely. Thanks for pointing that out. I have it in a GitHub repository. It's I will open that up, and yeah, chaos load Dapr, github.com. Daniel Meixner, chaos load Dapr. I will put that in here so that you will find it.
Yeah, that'll be great. Thank you. Because I think there is a chance here for us to also incorporate this in our automated test. So we can actually validate this, even like resiliency feature actually itself.
Okay, great.
Thank you.
great. Let me go ahead and grab the screen back. But while I'm doing that, any other questions about anything that we talked about today? Okay, so then next thing we have is just an open discussion. Can you guys see my screen again?
Yes.
Awesome. Okay, so now it's just any open topics or further discussion points people wanted to talk about. This would be a good time to do that. Okay. Not hearing anything from the community. Let's see if there's anything in chat. Don't see anything there either. Okay, so if there are no items that anyone wants to just talk about for a bit, or any questions that people have about anything we talked about earlier, I guess we can go ahead and close out the community call. But first,
there seems to be actually one question.
Yeah, there's
There-
a question from George.
oh, there is a question about Dapr adoption rate. How's it going? I guess I don't know how to answer that. I guess we're still seeing an increase in adoption. We've not necessarily been seeing too many new adopters adding to the adopter.md, but we do know we have a few different customers that are going, just users in general that are going into production with Dapr. I don't know.
I can also comment on just like the overall health of the project. I think.
Well, I also wanted to ask George if he could clarify his question a bit more. if not, Nick, you're free to just go ahead and answer the way you think is fit.
I think one way to look at this is some of the active contributors in the community that we're seeing, and I do believe, you know, that with looking at the dev stats from CNCF, the overall contributors' interest and engagement in the project is growing, and I look at that as a pretty strong signal that more users are, you know, using and adopting Dapr. I do believe there's a proposal to post some of these monthly contributing numbers in the Dapr community repo, so that folks can have better insight into that level of engagement in the project. I don't know. I know we have Arthur and Paul on the call from the SCC. I'm not sure if that proposal
that one
approved.
I think that one's starting with maintainers, but what we can do is share some links, like you said, in the dev stats. It's the data is all there, and you kind of look at contributors and you look at contributions, and it is steadily growing. And also, if you look at every release, like even the release notes, the list of contributors is growing too, which is a thing I like to look at. So I mean, it's one of those things in an open source. It's always challenging because we don't have phone home style telemetry, but these are the things we look at in a standard way.
Yeah, and also answering that in a slight different way, we're also looking into what are adoption blockers or the next unblockers for new scenarios. So on Dapr workflows is one of those investments that we're going through. And we expect that to allow people to adopt Dapr in ways that they were not thinking before. So so we're going to have more features coming up and more building blocks coming up in the next semester or so. So that is the planning we're going through now.
Awesome. There's another question. Any tentative date on when 1.9 will be generally available? So the release for 1.9 is planned for October 10th. That's the current release for that. Sorry, I'm looking at questions as I answer, but
yeah, October 10th, and we of course want to be ready with 1.9 before KubeCon. So
yeah, for sure. Any other questions? Also, I just pulled up our adopters at MD. We do have new people who have self-posted there, so I fibbed a little. That is growing.
I also pasted in a blog that came directly from CNCF where they listed Dapr as, you know, one of the top 10 top CNCF open source velocity projects. I think that was a neat place to show up with
Very
our
cool.
project. Yeah.
Yeah, and that was in late August, so that was not too long ago. Cool. Any other questions from folks? Okay, well, check out the links in the chat before we go ahead and close out so that you guys can still have access to it. But if there are no other questions on anything discussed or just other discussion points people want to ask, we'll go ahead and close up the call. Thanks everyone for joining.
Thanks. Bye-bye.
Thank you.
Bye.
Thanks.